Hey guys, happy Monday. This is our last week, so after this week, you are free for the summer. So, one more week, you got it. Hang in there, guys. Thank you to those of you who are watching. I know everybody is not, because I can see how many people are watching my videos. So, for those of you that are, I appreciate that you are still learning and you're caring about math. So, last week, pretty easy, not too bad. Math 7 again. You've already learned percent of change and simple interest. Pre-algebra, this is new to you, but nothing too bad. Pretty simple. So percent of change is a ratio that compares the change in the quantity to the original amount. So in order to find that, you're going to take the amount of change and divide it by the original amount. Okay, and then it's called the percent of change. So that means that it's going to be written as a percent. So when you divide a number like this, it's not giving you a percent. It's going to give you some type of decimal. Okay. You're going to have to change that decimal into a percent. That's the most important part that a lot of students always forget to do. So it's a percent of change. You have to actually write it as a percent. Okay, and we'll get to that in a little bit. So when you compare the amount of change to the original amount in the ratio, you're finding the percent of change. So the percent of change is based on the original amount. Okay, so it's based on that original amount. So that's why you're always dividing by the original amount. So original is always going to be on bottom. And then we have a percent of increase and a percent of decrease. Okay, so just as it sounds. If you're increasing, then it's a percent of increase. If you're decreasing, it's a percent of decrease. Okay, so if you're going up, it's increase. If you're going down, it's a decrease. You're finding it the same exact way. Okay, and you can even figure out if it's an increase or a decrease before you even start calculating. So let's look at example 1. And we'll go ahead and look at it. Okay, so in 1970, the gas was $1.30. In 2010, it was $2.95. So it was $1.30. Now it's $2.95. So what happened? Did the prices go up? Did they increase? Or did they go down? Did they decrease? So from $1 to $2, they went up. So I can automatically tell that this is going to be an increase. Okay, so it's going to be a percent of increase. And then, of course, we want to find that percent of change. And then we want to round to the nearest whole percent. Okay. So step 1 is to find out how much is it increasing. So super simple. You're just taking these two numbers and you're going to subtract them. You always want to take your larger number first. You're subtracting the smaller from the larger. So you will never get negative numbers. We don't want negative numbers. Okay. So $2.95 minus $1.30 gives me $1.65. So the price is changing by $1.65, okay? So when we're finding this percent of increase, it's the amount of increase divided by the original amount, okay? So the amount of increase is how much it's changing, which is what we just found. So then we want to divide that. So our $1.65, we're dividing by the original amount, okay? Original amount is always what was the starting price. So in 1970, that's the first piece of information we know, so that's your original cost, okay? So you're taking that $1.65, the percent of the amount of increase, and you're dividing by that original price, okay? So when you divide that in calculator, you're going to get 1.27, rounded, obviously. And then you have to write that 1.27 as a percent, okay? So remember, if you're going from decimal to percent, you can either move that decimal place 2 places to the right, or you can simply just multiply by 100, okay? So you could have also done 1.27 times 100, and it'll give you that 127, okay? And that's in a percent, okay? So either move your decimal 2 places to the right, or just multiply your answer by 100, okay? So that means that the cost of gasoline increased by about 127% from 1970 to 2010. Please remember to put that percent sign in your final answer, okay, because it's a percent of change. So put that percent sign there. Okay, so not too bad. Let's look at another example. It says Youssef bought a DVD recorder for $280. Now it's on sale for $220. Find the percent of change in the price and round to the nearest whole percent. So he bought it for $280. It's now on sale for $220. So thinking about a percent of increase or percent of decrease, what do you think? It's on sale. So if it's on sale, are you spending more money or are you saving money? You're going to be saving money. So obviously it's going to be a decrease. It was $280. It's on sale for $220. So it's less now. So this is a percent of decrease. Okay. And now we want to find out, okay, how much did it decrease? So you want to find the amount of decrease. How much is it changing? So you're taking $280 and you're going to subtract $220. So it's changing by $60. Okay, remember we always want to take that larger number first. We never want to get a negative number. If I do 220 minus 280, it's going to give me a negative 60, and I don't want that. Okay, so you always want to deal with positive numbers. So it's changing by $60. So now you're going to take that original amount and you're dividing by it. Okay, so 60 is how much it was changing. It was originally $280, so I'm dividing by 280. So 60 divided by 280 gives me 0.21 rounded. And then you multiply that by 100 or either move that decimal place to the right. Okay, so that gives you a 21%. So it was decreased by about 21%. Okay. So please remember to change that decimal to percent. Okay. And again, like I said, it's going to be rounded, or these are rounded answers. 60 divided by 280. So you get 0.21428, whatever. Okay. You're rounding to the nearest whole percent. So even if I move my decimal place, okay, once I move it 2 places, it's 21.4. Well, 4 is smaller than 5, so that's why you just drop it off and it becomes 21, okay? Or simply, if you just multiply by 100, you get 21.4. So again, you can look at that, okay? 4 is smaller than 5, so you're just going to drop it off and it becomes 21 because you're rounding to the nearest whole percent. You don't want a decimal, okay? So if it gave me 21.5, I would round that up and it would become 22%. Okay, so don't forget those rounding. How to round. Okay. So a couple examples on our own. So example A says to find the percent of change from 10 yards to 13 yards. Okay, so is it going to be an increase or a decrease? We're going from 10 to 13. So we automatically know that it's going to be a percent of increase. Okay, so my final answer is going to be a something percent increase. So we can go ahead and put that if we want to, so we don't forget. Okay. All right, so we're going from 10 to 13. So they kind of do step 1, step 2. You can totally do this all in one step, and this is how I always do it. Okay. I know that I'm going to take the amount of change and I'm dividing it by the original amount. Okay. So I'm figuring out how much did this change. So I'm going to do 13 minus 10. And then what was the original number that they gave me? We were going from 10 to 13. So that first number, that original number is 10. And you're always dividing by the original. Okay. So 13 minus 10 is 3. So then 3 divided by 10. Okay. It's going to give me a repeating decimal. Or no, sorry, 0.3. Okay. So that's 0.3. Well, you have to change that to a decimal. So remember, either move the decimal place 2 places to the right. So if I move it 2 places, that means I have to add a 0. Or if you just hit times 100 in your calculator, that's going to be 30. Okay. So this is going to be a 30% decrease. Okay. Or increase, sorry. So our answer is a 30% increase. So you're just taking the 2 numbers and subtracting them for that top number. And you're dividing by the first number that they give you, that original. Okay. All right, and then B. The price of a radio is $20. It's on sale for $15. What's the percent of change in the price of a radio? So it was $20. Now it's $15. So did it increase? Did the price increase or did it decrease? It obviously decreased because it was on sale, okay? So it's going to be a percent of decrease. And then we want to find out how much did it decrease, okay? So we went from 20 to 15. So again, 20 is larger, so I'm going to do 20 minus 15. Because you're just finding how much did it change, okay? And then it was originally $20. So my original amount is 20. So that's what's going on the bottom. So 20 minus 15 gives me 5. So 5 over 20. So 5 divided by 20 gives you 0.25. And then multiply that by 100 or move it 2 places to the right. And that becomes a 25%. Okay? So that means it's a 25% decrease. All right. Now we have a percent error. Okay, so they're basically the same thing. It's just a different context. Okay, so we're trying to find out how much did I make a mistake. Okay, so if you guessed something, you're finding out. Okay, I guessed 10, but it was actually 20. So how much error was there? So it's very, very similar. The percent error is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. So we're still comparing it to the actual or to the original, okay? So actual is always going to be on the bottom, okay? So not the guess. So if I guess 10 and it's 20, 20 is going to be the bottom number, okay? Your guess is never going to be on bottom. So the actual amount is always going to be on bottom, just like your original is always going to be on bottom for percent of change. Okay. So finding the percent of error is similar to finding percent of change. Instead of finding the amount of increase or decrease, you're going to find the amount of an estimate, or the amount that an estimate is greater or less than the actual amount. So you're still just subtracting two numbers. It's just instead of subtracting the increase, how much it's increasing or how much it's decreasing, you're finding how much were you actually off, okay? So suppose you guess that there are 300 gumballs in a jar, but there's actually 400. So your actual is always going to be on bottom. So there was actually 400, so that's why I have 400 on bottom, okay? And then you're finding, okay, how much was different. You guessed 300, but it was actually 400. So you're subtracting the two. 400 minus 300 gives you 100. So 100 divided by 400 is going to give you 0.25. And then change that to a percent. So it's 25%. Okay. So super similar. It's just the words are a little bit different. Okay. Okay. So example 3, it says, Ahmed wants to practice free throws. He estimates the distance from the free throw line to the hoop and marks it with chalk. Ahmed's estimate was 13.5 feet. The actual distance should be 15 feet. Find the percent error. So again, they've done it in step 1 and step 2. You can totally do it all in one step like I did percent of change. Okay. So what you want to do is you want to find how much is he off. So the actual is 15. He estimated it was going to be 13.5, so just subtract those two numbers. So that means the amount of error was 1.5 feet. Okay, so that's going to be your top number. So your amount of error, 1.5, divided by the actual amount. Okay, the actual distance should be 15. So that 15 is going to be on bottom. Another bird, just like last week. Okay, so 1.5 divided by 15. It's going to give you 0.1, and then once you change that to a percent, it's going to become a 10%. Okay, so the percent of error is 10%. Okay, so pretty much the same, like I said, just a little bit different wording. So find the percent error if the estimate is 230 and the actual is 245. Okay, the actual is 245, so that's what's going to be your bottom number. Okay, so you're going to be dividing by 245. Because that's the actual. So then to find the amount of error, you're just going to take those two numbers and subtract. So 245 minus 230. So that's going to be 15 divided by 245. Okay. So 15 divided by 245. Whoops. Gives you 0.0612. So again, we're rounding to the nearest whole percent. So I'm going to move that decimal 2 places to the right. So it'd be 6.1, which is just going to be 6%. Or go ahead and multiply by 100. 6.1, you're just going to drop everything off. So this is a 6%. Okay. So the percent of error was 6%. So 6% error. Okay. So steps are still the same. If it's percent of change, then your original amount goes on bottom. If it's percent of error, then it's the actual amount. Okay. So a couple more problems down here on guided practice. You can go ahead and do these by yourself. Pause the video if you want to, and then check your answers. Kind of like what we do in class. So find the percent of change, round to the nearest whole percent. State whether it's a percent of change, percent of increase or decrease. Okay, so tell me if it's increasing or tell me if it's decreasing. So 30 inches to 24 inches. So we went from 30 to 24, so it got smaller. So I know it's going to be a decrease. So I can go ahead and write that. And then I want to find that percent of change. So I'm going to take the 2 and subtract. So 30 minus 24 and divide by your original. So the original in this case is 30. Okay. So 30 minus 24, sorry, is 6. So 6 divided by 30 gives you 0.2. So that 0.2 is going to be 20%. Whoops, not times 20, times 100. What in the world? 6 divided by 30 times 100. There we go. This would be 20%. Okay. So this is a 20% decrease. Okay, number 2, we're going from 126 to 150, so it's getting larger, so I know that this is going to be a percent of increase. Okay. So then in this case, I want to do 150 minus 126. And then the original is 126, so you're dividing by that. Okay. So 150 minus 126 should be 24. Divide 24 by 126. 24 divided by 126 gives you 0.190, so that's just going to be 19%, okay, because it's 0.0, so you just forget about it. So that's a 19% increase. And then number 3, we're finding the percent error. So Jessie estimates the weight of her cat to be 10 pounds. The actual weight is 13.75. So remember, actual goes on bottom. So you want to find how much is it changing. So 13.75 minus 10. And then you're dividing by that 13.75 because that's your original, or your actual, sorry. So 13.75 minus 10. And then divide that by 13.75. So you get actually 0.27 repeating. So that's just 27%. So this is a 27% error. And then if you want to do number 4, you can explain how the two amounts of change can be the same, but the percent of change can be different. So obviously it's based on the original amount. if say the percent of the amount of change was 5 for 2 different problems. Well, the first problem, your original number may have been 20, but the second problem, the original number may have been 30. So your amount of change is still the same, but the original amounts are different. So that's how the whole percent of change is going to be a little different. Okay, so that bottom number can change everything. All right, so that is percent of change and percent of error. So that's all your notes for today, and then you have work for tomorrow. And then there's your answers to check your work. And then we also have some more notes on Wednesday. Okay, so I'm going to go ahead and do those notes right now. So just like last week, all the notes are in one video. But you can pause the video now and you can come back to this on Wednesday if you would like. So simple interest. So simple interest is the amount of money paid or earned for the use of money. So if you're borrowing money from the bank, you don't just get to borrow it for free. Okay, they're going to charge you a percentage, and that's what this is. To find the simple interest, which we're going to say is I, you use the formula I equals PRT. Okay, so here's your formula right here. The principal stands for the P, and it's the amount of money deposited or invested. So how much money you're borrowing or however much money you're putting into the bank. The rate is the R, which is the annual interest rate, which is going to be written as a decimal. Okay. And then the time, which is T, is the amount of time invested in years. Okay, this is important. It has to be invested in years. So if they give it to you in months, you're going to have to figure out, how do I change my months to years? Okay. So example 1 says to find the simple interest earned in a savings account where $136 is deposited for 2 years if the interest rate is 7.5% per year. Okay. So we're finding simple interest. So we're going to be finding I. We're using that formula again, I equals PRT. So remember, PRT, that means P times R times T. So your P, your principal, is the amount of money deposited or invested. Okay. So here it says that 136 is deposited. So your P is 136. Your R is the rate at which it's invested. Okay. So it's written as a decimal. So it's deposited for 2 years if the interest rate is 7.5%. Okay, so this is your R. It has to be written as a decimal. Right now it's written as a percent. So again, a percent of change, we went from decimals to percents. So we moved that decimal 2 places to the right. Well, here we're doing it opposite. So we're going to be moving that decimal 2 places to the left. So that means you're going to have to add a 0 there. Okay? Or you can divide by 100. We multiplied by 100 for percent of change. So doing the opposite, you can divide. Okay. Have to remember to change that percent to a decimal. So 136 times 0.075. And then the deposited for 2 years. Okay? And it's already in years, so we're just multiplying by 2. So then you just multiply all 3 of those numbers. So your interest is 20.40. It's money, so remember to put that dollar sign with it, okay? So you're just multiplying all 3 of those numbers given to you. The main thing you just have to remember is to change your rate into a decimal and then pay attention to see if your time is in years, okay? So example 2, it says find the simple interest for $600 invested at 8.5% for 6 months, okay? So first, the money that I'm invested, I know that that's going to be my P, okay? My R is 8.5%, but remember, you have to change it to a decimal. So the R that you should be using, you're going to move that decimal place 2 to the left. So your decimal that you're using should be 0.085, okay? And then you're investing it for 6 months, okay? Your month has to be converted into years to use it in your formula. So 6 months, that's easy to tell that it's half of a year, but it's not always going to be 6 months, okay? So say that it was 3 months. Well, how do you know how many years 3 months is? So you're always just going to divide by 12. There's 12 months in 1 year. So you're just going to take your month and you're going to divide it by 12. Okay, so obviously 6 divided by 12 is 1/2 or 0.5. Okay, so you're always just going to divide by 12 to figure out it in years. So we're going to have 600 times 0.085 times 0.5. And that's what they've done here. So when they multiply them together, they get 25.5. Add that 0 to it because it's money. So $25.50 is the interest. Okay. So I'm just going to do, let's see, I'll do the even since we have a couple of fractions there. And then if you want to do the odds, you can. Okay. So $650. So in this case, it's not word problem. So it's just giving it to you in principal, rate, and time. Okay. So you're just multiplying all three of these together. But you're going to have to change them. Okay. So I equals PRT. So P is 650. R is 8%. Remember, you have to change that to a decimal. So that's going to become 0.08. Okay, you're moving it 2 places to the left. And then 3 years, it's already in years, so we don't have to change anything there. So when we multiply all that together, 650 times 0.08 times 3, that's 156. So it's $156 in interest. Okay. Okay. Number 4, my principal is 735. So 735 times 7% as a decimal, that's 0.07. Okay. And then 2.5 years. So you can just go ahead and multiply by 2.5. I'm going to change that to a decimal. So it's easier to plug in my calculator. And we know that 1/2 is 0.5. Okay. So 735 times 0.07 times 2.5 gives you 128.625. Okay, remember it's money. So we're rounding to 2 decimal places. So that 5 tells me that to add 1 to my 2. Okay, so this is going to be $128.63. Okay, so that's how much your interest is. All right, number 6, I equals PRT. So P is 2,105 times 11%. So 11% as a decimal is just 0.11 times 1 3/4 years. So again, we're not having to change that because it's already in years. 3/4, we should all know, is 0.75. So I prefer decimals, so I'm going to write this as a decimal, so 1.75. And then you don't have to convert anything because money is in decimals. So if you plug this in as a fraction, it's most likely going to give you a fraction answer. So you're going to have to change your fraction answer into a decimal because it's money. So if you just go ahead and change it to a decimal to begin with, then it's going to give you a decimal answer and you're done. Okay. So 2,105 times 0.11 times 1.75. So again, we're going to round. So that's just going to be 405.21. So $405.21 is your interest. Now number 8, my time is measured in months. Okay, so this is where we have to change months to years. So you're simply just going to divide by 12 because there's 12 months in a year. Okay, so 3 divided by 12 equals 0.25 years. Okay, so now you can multiply by 0.25. So that's going to be your T. Okay. So I equals P. P is 4,275 times your rate, which is 19%. So as a decimal is 0.19. And then times time in years, which was our 0.25. Okay. So then multiplying all those numbers together, you get $203.06. So $203.06. Okay. So remember to change your rates, your percents to decimals, and then change your months to years. Okay, so you can't just go through and plug all this in your calculator and multiply. You've got to change your percent to a decimal, and if it's in years, keep it, but if it's in months, you're going to have to change it, okay? So I'll just go ahead and do number 7 too, because it is 18 months. I know that might trip you up a little bit. So 18 months, we need to find out in years. So again, you're dividing by 12. So obviously, if there's 12 months in a year, 18 months means it's longer than a year, okay? So 18 divided by 12 is 1.5. So this is 1.5 years. Okay. So now that's your T. So now you can multiply 903 times 8.75%. So you're moving it 2 places. So that's actually going to be 0.0875 times your 1.5 years. Okay. So let's see, 903 times 0.0875 times 1.5. So that's 118.518. So again, that 8 tells me to add 1 to the 1, so 0.52. Okay. So $118 and what did I say? 52 cents. That's your interest for number 7. Okay. So if you want to, you can go ahead and do 1, 3, and 5. But that is your notes for Wednesday. And then your work Thursday is going to be all of your even numbers. And then Friday is going to be your odd numbers. And then you're done. That's all you have, okay? And that's your answer key to check your answers. So this is your last bit of 7th grade math work. Yay! So you've made it through. Again, let me know if you have any questions. Be glad to help. And I have enjoyed this year with y'all. Please come back and visit me next year so that I can see all of y'all, because I miss you tremendously. Hope you have a great summer and stay in touch.